So let's take a moment and look at an example from 6.1 and see how we can find the area and perimeter of a regular polygon. Okay, let's see this situation where Zach has an octagon that he wants to make for his gazebo, and we want to see how we could find the perimeter and area of this. So we saw that if we take this regular polygon, we can break it up into some triangles using some lines here. So if we draw them all in, we get something like this. And we notice that since this is an octagon, which means we have 8 sides there. Octagon has 8 sides, so we have 8 triangles. All right, so we have 8 triangles here. And we're going to need to find the lengths and areas of these triangles. Now, this is a radius of 2, and so we can label this as 2. So the radius, remember, is the distance from the center to the vertex. What's a radius? Radius of the circle and radius of the polygon there. All right? So what we need to do is we need to find the length of one of these sides. So what we're going to do is take one of these triangles, and whenever we're doing this, it's real helpful to draw a large version of one of these triangles, one of these kind of pieces of pie, and we'll label it as we go. All right, so if we take this triangle and blow it up, we get this. Now we're going to need to find a couple pieces here. We need to find this half side, and we're going to need to find this altitude here. We'll call it A. And those will help us find the area of the triangle and then the area of the whole polygon and the perimeter as well. All right, so first thing we're going to need is we're going to need to find the angles. Okay, so let's find the angles. We've got the central angle here. And to find each of these central angles, notice they're all the same. So we have the central angle is going to be 360. And we'll divide that by 8, and that gives us 45 degrees. So that means this whole angle here is 45 degrees. In fact, all of them are 45 degrees. And what we care about is we care about this half angle. So if we cut this in half, if we draw the altitude in of any of these triangles, we'll have half of 45. So this will be 22.5. Hopefully you're labeling this with us and drawing this out with us. So we have that half angle. Now that we have that half angle, we can use that to find the half side. We'll call this the half side. And then we'll use it to find the altitude. All right, so we're just focusing on the half side because we've got a nice right triangle here, and we can use our right triangle to find, to use trigonometry. All right, so let's use some trigonometry. Here we go. Let's start by finding that x there. We ask ourselves, what do we need, what can we use to find this opposite side if we know the hypotenuse? Well, opposite over hypotenuse is sine. So we can use sine of that 22.5. We know sine is opposite over hypotenuse. The opposite of it is x. The hypotenuse is 2. And we know the sine of 22.5 is some decimal. If you want to go find it right now, you can. But we really just need to multiply both sides by 2, because we know 2 times whatever that sine is, sine of 22.5, is going to be equal to x. And we go to our calculator. We can punch that sine of 22.5 into our calculator, and it'll tell us what that is. And it looks like that is 0.76536. Actually, we only need 4 decimal places there is good enough. So let's round that off to 4. All right, so we know the side length is going to be half of that. The side length is going to be doubled, and that's going to be 2 times 0.7654. And that's going to give us a side length of 1.5307. All right. And so that's enough. We can find the perimeter from that. And since it's an octagon, the perimeter is just going to be 8 times the side. So the perimeter, we have P equals 8 times 1.5307. And there There we go. All right, and that's going to give us a total of 12.54. Okay, so we found the perimeter. We'll round that off to 12.2 inches. So the big idea here is we find the half side. We found that out here, that x, call that the half side, and then we use that to find the whole side length. And then once we find that side length, since this is a regular octagon, we can multiply that by 8. All right, so that's what we're getting here. So what about finding the area? Well, we know the area is area of a triangle is 1/2 base times height. All right, so let's find that area of the triangle, and then all these triangles are the same, so we can multiply it by 8. All right, let's do that. Okay, so we're going to go ahead and start. We need to find A here because area of a triangle is 1/2 base times height. All right, or specifically for this, we have 1/2 times S times A. A is the altitude, and S is the side. Okay, and we're actually going to have another name for the altitude. We're going to call that the apothem. We'll talk more about that later. So the altitude is really called the apothem of the regular polygon. All right, so that's what we want to do. We want to find the area of the triangle, then we'll multiply it by 8. Well, how do we find this A value? Well, notice that is adjacent to this angle. So we have adjacent and we have the hypotenuse. What uses adjacent and hypotenuse? Well, cosine does. So let's write a cosine formula. Cosine of 22.5 equals A over 2. And that should be an easy equation to solve. We want to multiply by 2 on both sides to get that 2 out of there. And so we have 2 times the cosine of 22.5. And that's going to give us the altitude. So we'll go to our calculator, and we'll say we got 2 times the cosine of 22.5. And that's going to give us 1.8478. We'll round it off to. All right, so there's our altitude. Well, now if we want to find the area, we have 1/2 times the side times the altitude there, or the apothem. Well, we know the side, right? We found the side length right here. So there's our side length. Okay, so we have our area of the triangle. Our area of the triangle, and it's useful to note, like I'm doing there, triangle, because we haven't talked the whole polygon yet. So we have 1/2 times the side length, which is 3.8268, times the altitude, which is the number we just found, 1.8478. Okay, that's going to give us the triangle. And then when we put that in our calculator, we get 3.5355. Okay. Now that's one triangle. Okay, so keep in mind that's one triangle. So the area of the octagon, what do we have to multiply that by? Well, again, we should, octagon means 8, so multiply that by 8. And we're done. All right. So keep track of what you are multiplying here, and keep the numbers in your calculator. Just do 8 times the answer here, 28.28, and that's good enough. 28.3 would be good enough too. And this is square inches because area is in squares. All right, so that's the process there. Okay, so it's all about this triangle. Draw this triangle out, label it just like we did here. Find the angle, And then you should be able to go from there. So flip to page 9 real quickly, and let's summarize this real quickly. So we want to just imagine that we have some regular polygon here. We don't know how many sides it has. The key to this is focusing on one of these triangles, all right? So you want to draw out one of these triangles and probably draw it out large. You don't need to draw the whole thing if it's not already drawn for you. But we need one large triangle. You need to draw that out and then label it. Let's call this half side X. And let's call this altitude, or the apothem, A. Okay, so step 1 is to find the central angle. We need that for any of these. Step 1, we need to find the central angle. All right, so once we find that central angle, and we'll call that angle A, capital A there, that's going to be 360 degrees divided by the number of sides. Okay, and that will give us our angle A. All right. So now that we have that angle, we can find X if we know, suppose we know the radius. The radius is kind of important there, okay? So for the perimeter, we need to find X. And to do that, we're going to use, in most cases, it might change. It depends on what we know. The sine of the angle is R over X. Okay, and then to solve, once we can find that half side, the perimeter would be 2 times that half side times the number of sides. Okay, so note that we have n sides. That's important. All right, almost done here. So we have n sides, and then that's to find our perimeter. Well, to find our area, we need to find A. And to find A, again, usually, if we know the radius, we're going to use cosine. All right, so we can use cosine. In some situations, we might use sine or tangent. Depends on if we know other information. And so we can find A using that equation. And so then we can find the area. The area of the polygon, and that's going to come from the triangle. So we have the triangle, which is 1/2 times the altitude times the side length, because you're going to have to find the side length. And then we're going to multiply that times the number of sides. Okay, so here's our equation for area. Turns out to be 1/2 the altitude, or the apothem, times the side length times the number of sides. And the perimeter is the number of sides times the side length. So S times N. Okay. All right, so that's enough to kind of get going and get into this here. Again, for each of the problems in the set problems there, you're going to want to draw, not the whole thing, but just draw one big triangle and label it as you go. All right, label it with all the things you know. It does take several steps, but persevere and you'll get through it.